grade 12 trigonometry is all the trigonometry that you've learned in grade 11 as well, but just with something added to it. And that something is the compound angles, and then after this, the double angles. There are new formulas. Just like you know that sin squared plus cos squared is equal to 1. That is an identity. These are identities. Now these identities are the following. Now you're going to learn it off by heart. That if I have sin of two angles added together or minus, as well, I'm going to write the minus one just now. If it's two angles added together or subtracted from each other, that's why we call it a compound angle, because it's two angles that are added together and they can be subtracted. So it's compound angles. So when I do these compound angles, I have the formula going. It's a little pattern. So we're going to say sin A plus B is going to be, I'm going to teach you sin, cos, sin. It's a little pattern, a little rhyme that you've got to go and teach yourself. And then you're going to use the angles A and B. A, B. And if there's a plus there, then this will be a plus there as well. If you look at the deduction and reduction formulas and how they got there, this is the fact. You just now have to know it. That whenever it's sin, the pattern's going to be sin, cos, sin. And the plus will stay a plus. So now the thing that can change is there could be a minus. Then the only thing that would change is that there would be a minus. So it's still going to be sin. A and B and alpha and beta, doesn't matter what they are. Again, with the sin it's going to be sin, cos, sin. It's going to still be A, B, A. The other one is the cos compound angle. Now the cos compound angle works that it's cos, sin. So the way that it works with the little pattern with cos is that it's cos, sin. Now guys, this is on your formula sheet. So you can't really forget it. But if you know it, then it's so much easier to do the work. So cos, sin. The angles, A, B, but then the trick comes in. If this was a plus, then this is going to be a minus, and if this is a minus,
it's going to be a
that
plus.
would be a plus. And that's it. That's what you've got to go study. Then if I've got cos A minus B, it's going to be cos, sin. Now let's go and look at how it's practically done. Now you might have wondered for a minute, what about tan? If I had tan of two angles added together, how would I do that? Because you're not taught that. There is a formula for this. You're not taught that because you can get from tan to sin over cos. But that just is quite horrible. So that'll be a compound angle formula at the top and a compound angle for cos at the bottom. Because remember, when it's sin over cos, it's the same angle. Alright, let's get to the questions. The question says, simplify without a calculator. What does without a calculator imply to you?
Don't use a calculator.
Should be special angles. Are you with me, guys? Hear what I'm teaching you.
Yes,
If
ma'am.
you hear the words without a calculator, you should know there should be special angles. What's going on here? 10, 50. That's not special. What's that? So you've got to now that you have the new information, be able to recognize. But this is this. Sin, cos, sin. So if you have sin, cos, sin, that should now, after teaching you the little recipe, the little rhyme, should trigger something. If it's sin, cos, sin, which one is it? It's the sin compound angle. It's something that you're taught and that you must now from now on know. So sometimes you're going to go from here to there and sometimes you're going to go from there to there. Because both is true. When? Every sum is different. That's always been the beauty or the horror of Trig. Every sum is different. So if I have to carry on with this one, and I know it's sin, cos, sin, and you guys told me it was the sin compound angle, and don't forget your brackets, it's important. Compound what?
10 plus
So 15 and the 50. Yeah, are you sure that it's plus?
Yes.
Because the sin one stays the same sign. But in the cos one, the sign, whatever it was, changes. So if it was minus, it must be plus. Was plus, it must be minus. This was plus and stays plus, and that makes you feel quite comfortable because now this is going to be a special angle. That's why the question said no calculator, because it does get to a special angle. And then the sin of 60,
Root 3 over 2.
which your calculator will tell you that, but guys, remember, if you are studying for NDT tests and you're not going to be able to take a calculator in, how are you going to know what sin 60 is? So you've got to know what you're preparing yourself for. Okay, let's have a look at the next one. Do you see a problem?
Yes.
What's the problem?
It's not a compound.
It is a compound angle, but you've got to work with this. Cos, this people are crazy. Cos, sin. There's nothing like that. And look at the angles. It's all over the show. At least there's a 67 and there's a 67. What else do you see? See that one? This is the same. But cos 22? Cos 22 is? Sin? If I take this cos 68, I can make it?
Sin 22.
How?
It's
Because you're never getting away from your basics. This is co-functions. But you need to get the angles the same. And you need a pattern. You need cos, sin. But now these are swapped around. But that's not a problem. If I do cross it around, this one will just for your sake for now, let's say sin 22. Because it doesn't matter if it was swapped around, remember? If it's A times B or B times A, same thing. Just so that you can better see that it is cos, sin, 67, 22. So this will definitely be a compound angle of cos. You can't write sin. You've got to know your stuff. And then the 67 and the 22 must be? Minus. And then I'm happy again because that gives me a special angle. And cos 45? Which if you knew it from little triangles, you might have said 1 over root 2. But remember, we never leave it with a root underneath the line. We rationalize the denominators. Wasn't there another way of doing the sum? There's always going to be another way to do the sum, because just what we've done here, using your co-functions, you could do everywhere. If I really wanted to make myself some trouble, I could have made lots more work. I could have changed this into sin cos, and then I would have wanted this as cos sin. You wouldn't do that because that means not changing just one, but changing a few things. So if you have a choice, just change the one instead of maybe 2 or 3 things. So I'm saying let's just prove a point. If I did want to change that into sin 60, well, if I changed it into sin, it would be sin what? How much to 290? 23. Well, now I've got another thing. Are you with me here? If I change that into sin 23 and kept this as cos 22, I'm aiming for sin cos sin. Are you with me? Yes. So that I can get to a sin compound angle. If I did that, then obviously here I would like cos 23. Where would I get cos 23 from? That would give me cos 23. And then the sins of the cos 68 give me a sin 22. Are you with me? Now, how many of these things have I changed? That one and that one? Oh, no, too much. Not a good choice, but it's perfect. And then the sign still stays plus. Now that I've got sin cos sin, it's going to be a sin compound angle. So the memo is all over the show. You've got like alternative, because you can do all sorts of things. But now if it's 23 and 22, it's going to be plus because it's the sin one. And you still get into sin 45. Oops, but that's not cos 45, or is it? Is sin 45 and cos 45 not the same?
It is.
because it's cofunctions. And you don't even have to go that route. You can just say, well, do the special angles, and it's again going to be root 2 over 2. Exactly the same answer, completely different technique. To show you that you could have chosen to go for sin, cos, cos, sin. This guy went for cos, cos, sin, sin. This guy, I think, made himself a lot less work because he only changed that into that. And help yourself to always have it in the correct order. Because it's not, doesn't matter if you wrote sin 22 in the front and the sin 67 stayed at the back, it's fine. But then when you start putting it in here, especially in the beginning, you might get confused with which one goes in the front, especially when it has to be subtracted, you might have a problem. So get it always in that little recipe. Sin cos, cos sin. Or cos cos, sin sin was that one. Alright. Alright, if the question asks you some sort of stuff, it's because we get going towards bigger questions, harder questions. Now the question here says, write this as a function of 15. I'm never going to do that. Well, never say never. But we won't do that. But in a sum, you know those big reduction formula sums that you've got to reduce and cofunction and special angle and everything in one sum for 8 marks. This could be part of it. There would be a reason why I would want to change this into something that has a 15 degrees in it. Okay, but that being said, just answer the question. If I want to change that into a function of 15, what would you do? Your basics still stay the same. What do we do?
You have to like get
180?
No, not minus
plus 15. All your reduction formulas are still there, including your cofunctions. Are you with me? Even negative angles? Yes. Are you with me, everybody? Even larger than 360, it could be 1,000 and something degrees. You still have to be able to reduce to less than 360, reduce to not a negative angle. This case, you will reduce into 180 plus. Do we ever write this anymore? Yes. Well, I've just done it, but I never do that. I immediately write that this answer is sin 15. How do I get there? By saying 180 plus. But then, very important,
the sign.
You have to have the correct sign. So if you have that, you've got to say it's minus 15. Not there, because this is still just the same. That is exactly equal to each other. But doing the reduction formula, why is it negative? Because I am in the third quadrant where sin is negative. And that was it. That was the question. What a silly question. Because most probably you'd see something like this inside of one of those big reduction formula sums where they can cancel out. Okay, now another one. Do without the calculator, which means what?
Special angles.
Special angles. So what's so special about 75?
You have to do something.
You have to do something exactly. Okay, now obviously what are you going to do? What am I teaching you today?
45.
Make it a compound angle, excellent. In which what happens? You've got to get 75. But please don't say 70 plus 5. That's true, but where are you going?
I'm not going anywhere.
Okay. You need to get to?
Special angles.
How am I going to get to special angles?
30 plus 45.
Fantastic. 30 plus 45 or 45 is 13, doesn't matter. Why am I forcing it there? Because I'm not allowed to use a calculator. And 30 and 45 are my
Special angles.
Then when I'm there, I've made it a compound angle and now I've got to elaborate. I've got to and write it as?
Cos 30, cos 45.
First say cos. Cos. Please give me the recipe first.
Oh.
Cos.
Sin.
With the angles. 30, 45.
Minus.
30, 45. And if it's plus and it's cos, this will be a?
Minus.
Minus. Once you have it, you can't lose it. But it's a lot of things. And now I'm definitely not finished because they said calculate this without a calculator. How?
Special angles.
How many?
4.
For how many marks?
1.
1. Because we can do one special angle, you can do all 4 of them. We're not going to give you 4 marks for that. So, cos 30.
3 over 3.
Okay, cos 45. Sin 30. Oops. I said 30 and then I write a 3. And And now guys, can you use the calculator now? Absolutely, that's not what the question was about, saying not a calculator. Please do the calculator and just give me the answer. Because it's not about, do you know how to time this? And do you know how to time that? And do you know how to subtract with fractions and LCDs and what? That's not what the sum is about. It was about, do you know you've got to go to compound angles? Do you know the compound angle rule? Do you know that it's special angles? The answer, please, if somebody can give it to me on a calculator.
Root 6 minus root 2 over 4.
I'm happy. Everybody's happy.
Yes.
Now, if you were in the MBT tests, unfortunately, you would have to go and time it out and get. This is root 6. Do you see it?
Yes.
Because two roots timed with each other, you put them in one. And 2 times 2 is 4. And over here you've got root 2 over 4. You see that where the answer comes from?
Yes, ma'am.
But you didn't have to worry your pretty little brain about that. You could just put it in the calculator, get me the answer. Got it? Okay, you ready for some homework?
Yeah.